Hello everyone and welcome to my channel. Today we are going to talk about fluid dynamics and we are going to solve this problem together to solidify our knowledge of this same concept. Without further ado, let's hop right into it. This question reads, water flows through a horizontal pipe with two sections. The first section has a diameter of 0.1 meter and the second section has a diameter of 0.05 meter. The water velocity in the first section is 2 meters per second and the pressure is 200,000 pascals. Assuming the water is incompressible and applying Bernoulli's equation, find the velocity and pressure in the second section of the pipe. We assume no energy loss due to friction. Before we solve this problem, please permit me to define certain key terms which are related to this same problem. The first one that I want to talk about is what we call the section. What is the section? This section is also called a cross-sectional area. So if you look at this right now, you will discover that this pipe has an opening. This is a pipe. It's a horizontal pipe, which means it's not resting on any surface. It's just on the ground, right? Now, water is going to flow from outside into the first entrance, and this first entrance here is called the first cross-sectional area. Okay, so see this section as a door or as an entrance through which water enters the pipe. So the first cross section or the first section is an entrance, okay, and we call it A1. All right, so A1 refers to the first cross-sectional area. So whenever you see a question like this or you read a question like this and you come across the word section or first or second section, don't get confused. Section simply refers to entrance. Okay, so the first section is the first entrance, while as it exits the pipe, it's going to leave through the second section, which we call A sub 2. All right, so this is the first door and here is the second door. Okay, this is where it enters and this is where it leaves. So that's the simple explanation in terms of section. The second thing that you also need to understand is that this water is going to flow with some velocity. It's going to pass through the first section with some velocity, and this we're going to call it V1. Okay, it's going to have some speed or velocity as it enters through the first cross-sectional area or through the first section, and it's also going to leave, all right, with some velocity. It's also going to leave the pipe at the second section with some velocity, which we call V sub 2. So this one means A1, V sub 1, A2, V2, all right? So this is actually the continuity equation which we use to calculate the velocity or let's say the cross-sectional area or whatever, considering the fact that this pipe is not leaking. The pipe is not leaking and there is no friction. If the pipe were leaking, it means that the volume of water which is entering this section is not equal to the volume of water leaving the other part. So the volume of water entering through here must be the same with what is leaving through here for you to use this very equation, which is A1 V1 is equal to A2 V sub 2. If the pipe is leaking, you can't use this equation. Okay, so that is just how it is. But in this case, the pipe is not leaking and there is no friction, which means that no energy is lost. So we have to use the continuity equation. Let me define some parameters in this equation. You can see that this A1 or A sub 1 refers to the first cross-sectional area, and area is equal to pi r squared. This is the formula, right? And secondly, you also need to understand that we were given diameter. Okay, we're given diameter, so we cannot actually use this value as it is, we must convert from diameter to radius. Why? Because in the formula for area, it has r, and this r is radius, okay, not diameter. The pi's can cancel out when you start solving, but this radius cannot cancel out. You must find their equivalents and plug them in here before you can start solving. So that means that we are going to convert diameter to radius. And you also need to understand that diameter and radius are related by the formula d, which is diameter, is equal to 2r, right? And to solve for r, what do? You divide both sides by 2, and therefore r is equal to diameter divided by 2. So this simply means that we are going to divide our diameter by 2 to get our radius. Now when we find our radius, we substitute it into this very formula here and solve. All right. Now let's try to make velocity 2 the subject of the formula, because that's what we're looking for. If you look at this part, they gave us the first velocity, which is 2 meters per second. The second velocity was not given, so we have to look for it. But we're given our diameter for the first cross-sectional area and also our diameter for the second section. So with this, we can solve for our velocity. Before we solve this problem, let me give you one more explanation on this same concept. The wider the cross-sectional area, okay, the higher the pressure. The wider the cross-sectional area, the higher the pressure. The more constricted the cross-sectional area is, the lower the pressure. This is an exam tip because some students, they don't really understand this very concept and they go on to solve whatever they like and submit their solutions. See, let me give you one exam tip. As in this question, you have that your pressure at the first section is 200,000 pascals. You are expected to get a pressure less than 200 pascals at this end, because the wider the cross-sectional area, the higher the pressure, and the more constricted the cross-sectional area, the lower the pressure, which means this part here is wider than the second part. And if the pressure right here is 200,000, you're supposed to get a pressure less than 200,000 right here at the second section. Okay, that's it. So you should not get a pressure higher than 200,000 at this end. If you get it, it means you have gotten it wrong or the question is wrong. So this velocity must be less than, or this pressure rather, must be less than 200,000 pascals. And secondly, the wider the cross-sectional area, the lower the velocity. Right here, we've discovered that at our first cross-sectional area, our velocity is 2 meters per second. And the more constricted the cross-sectional area, the faster, okay, the higher the velocity. That means that the water is going to flow at a faster rate compared to this very part. And that means that the velocity that you're going to get right here should be higher than 2. If you solve for this part and get a negative velocity, then you're wrong. If you get a velocity less than the initial, then you're also wrong. Your velocity here must be higher than your initial velocity. That is just how it is. This means that the velocity with which it enters the pipe, okay, must be lower. The velocity with which it enters must be lower with the velocity with which it leaves. Okay? And in other words, the velocity with which it leaves must be higher than the velocity with which it enters. So if you have a 2 here, we must get a number greater than 2 in this very case for our solution to be correct. Now let's solve this very problem together. Here we have a sub 1 v sub 1 is equal to a sub 2 v sub 2. This is a continuity equation. So let's now make v2. Since we're looking for v2, we can make it a subject of the formula and then solve. So we say we divide both sides by a sub 2, a sub 2. The a sub 2, they cancel out. we now have that V2 or V sub 2 is equal to A sub 1 V sub 1 over A sub 2. You have to remember that remember I said that A is equal to pi r squared. So wherever we see A sub 1, we replace it with pi r1 squared. And wherever we see A sub 2, we replace it with pi r2 squared. Let's do that quickly. Here we have that our V2 is equal to, here we have pi. Remember that area is equal to pi r squared. So we say pi r1 squared or sub 1 squared to differentiate. Okay. Now this is multiplied by our first velocity. Remember that we got a 2, right? We got a 2, or we're given a 2. This is all over. Our A sub 2 is also pi r sub 2 all squared. Okay, so now let's look at this very closely. This pi on top and the pi at the bottom, they're going to cancel out. Now, why didn't I say pi 1 and pi 2? I did not say that because pi is a constant. It's a mathematical constant that does not change. Okay, so you cannot say pi 1 and pi 2. But if you look closely at the question, you will discover that we were given our first diameter and our second diameter, and the values were not the same. So when we cancel out the pi's, what remains, we now have r1 squared multiplied by 2 all over r sub 2 raised to power 2. All right. Now we're now going to use this very formula here to get our radius. And when we get the radius, we substitute it into this equation to solve for our velocity. For the first question here, for the first diameter, we're given 0.1 meter, and the other one is 0.05. Since they're already in meters, we don't have to do any conversion. But if they were given to you in millimeters, you must convert to meters. It's very important. So the first one is 0.1. Okay. So I'm going to say, let me solve this on another page. So we say our D1 is equal to 0.1 meters, and then our D2 is equal to 0.05 meters. Let me check if we're correct. Yeah, we are correct. So the next thing that we're going to do right now is that we have to use this very formula. We said that the radius is equal to d over 2. All right? So now let's plug in and solve to solve for the radius. And what is our radius in this case? Our diameter. For the first one, we have that r1 is equal to d1 over 2, and then r sub 2 is equal to d2 all over 2. Let's substitute. We said that our r1 is equal to, our first diameter is 0.1, okay, all over 2. And the second one, r sub 2 is equal to 0.05 all over 2. Remember, we're still solving for the radius. Now let's divide. For the first one, 0.1 divided by 2, it's 0.05. Here we have 0.05 meter. So our r sub 1 is equal to 0.05 meter. And then our r sub 2 is equal to, let's divide, 0.05 divided by 2 is giving me 0.025. Here we have 0.025 meter. Okay, now we have our radius. We can now go ahead and solve for the velocity too. Remember the formula that we wrote was v sub 2 is equal to, let me check it again. Okay, we have r sub 1 squared multiplied by 2 all over r sub 2 squared. You remember where we got this from? If you look at the solution that I provided here, we made v sub 2 the subject of the formula, and then canceled out the pi's, and we were left with r sub 2 multiplied by 2, where 2 is the velocity as we're given in the question at the first section divided by r sub 2 squared. Now let's plug in and we solve. All right, so our v sub 2 is equal to our first radius is giving us 0.05, but now we have to square it, and this is multiplied by 2 all over our second radius is giving us 0.025. We also have to square it. Here is where the value came from, and this is the first one here. Now let's solve and see what we're going to get. So 0.05 squared, this is equal to, here we say our V2, okay, is equal to, or let me do the calculation straight. So we say 0.05 squared multiplied by 2, okay. So this is giving me 0.005 all over the denominator, which is 0.025 all squared. Now let's do the math and see what we shall obtain. We have that our v sub 2, which is the second velocity, is equal to, let's see what we shall obtain here, 0.005 divided by 0.025 all squared. I'm getting an 8. So the answer is 8 meters per second. And this is right, because remember what I told us initially, that if your velocity at the first cross-sectional area is 2, what you're supposed to get at where it lives is supposed to be higher than where the section is wider, okay? If you have a 2 here, you're supposed to get a number greater than 2 here, and that means that you're correct. Okay, in most cases, you're correct. Now, the next thing that we're going to solve for right now, since we found the velocity, the next thing that we are going to solve right now is for the pressure. It says, find the velocity and pressure. We found the velocity. Now, let's go ahead and calculate the pressure using Bernoulli's equation. Now, the question right here is, what is Bernoulli's equation and how do we use it? So in this case right now, since there are two ends of a pipe, we're going to write down Bernoulli's equation and use it to solve this very problem right away. Now, Bernoulli's equation for two ends of a pipe is written as P1 plus half, this is rho, okay, V1 squared plus rho GH1 is equal to P2 plus half rho V2 squared plus rho GH2. Okay, so this is the equation, and this is what we're going to use to solve the problem. This is called Bernoulli's equation, okay? So since there is no friction, which means no energy is lost in the process. If you go back to the question and read, you understand what it says. It says, assuming no energy loss due to friction. If there is no energy loss due to friction, it means that energy is conserved, okay? The energy right here, the initial energy is equal to the final energy because friction is not there. Friction is like a thief that steals energy, right? But in this case, the fluid, the water is incompressible, and there is no energy loss due to friction. So Bernoulli's equation is a perfect equation to use to solve this very problem. Now, this is the equation that we're going to use to solve it. Now, let me define the variables in this equation. The P1 here refers to the pressure at the first cross-sectional area, okay, which is in this case 200,000, right? So the first cross-sectional area is, okay, the pressure at the first cross-sectional area is 200,000, And now the rho is density. Okay, the density of water is known to be 1000 kilograms per cubic meter. Okay, and then whenever we see density, we're going to replace it with this very value 1000. Okay, now assuming the fluid were not water, you will still be given the density of that fluid. Okay, it's always going to be given. And here the G refers to gravity. This is height. Okay, the height of the pipe. Okay, the H1 is the first height of the pipe, and the P2 here refers to the pressure with which it leaves, okay, or the pressure at the second cross-sectional area. Please pardon me for that. Now, this density here, which is rho, this is not a P. This is density. It refers to the what do we call it? The density of the fluid. Okay, but in this case, we're given water, so it has to be 1000. And now the V here refers to the velocity with which it leaves, which you found already. I forgot this one here. This V here refers to the velocity with which it enters. Okay, then that's why we call it V1. Now this one here is the velocity with which it leaves, and we call it V sub 2. Now this is also our density, which is 1000. The G is acceleration due to gravity, and then finally our second height. Okay, and now you have to also understand that in this very question, it says horizontal pipe, which means it is not on any surface apart from the ground, which means that the height is going to be 0. So you must look out for these keywords before you get confused in the examination hall. So if it says horizontal pipe, it means that it is 0. Okay, the height is 0. It's just on the ground. If no height was given in the question, please know that the height is 0. Okay, if it says it's on the ground, let's say it's on the ground while the other part is on a building, it means that your first height is on the ground, and if it's on the ground, it's going to be a 0, while you'll be given the second height, which is on the building. Okay, now let's plug in our values and then we solve. Okay, so here we say that our P1, which we're given, is 200,000 pascals. If you look at the question right here, okay, this is 200,000 pascals. That is our P1. So we say 200,000, okay, plus half. What is our density? Our density is 1000 multiplied by our first velocity, which is 2 all squared, plus our density is also 1000 multiplied by acceleration due to gravity, which is 9.8, and then our first height is 0. Okay, so permit me to copy everything here down because of space so that you can see properly. So this is equal to P sub 2 plus half rho, sorry for that. So this is our rho, V2 squared plus, okay, so for the second height, there is no height, it's just on the ground. So we say our rho multiplied by G, and then the height is still a 0. So we can now simplify this and see what we can obtain. So right here we have 200,000 plus half of 1000 is 500. So we now have 500 multiplied by 2 squared is a 4, right? Plus, but in this case, this is being multiplied by 0. So 1000 times 9.8 times 0 gives you a 0. This part goes away. Now we now have this is equal to our P sub 2, which is our second pressure, plus. Now let me substitute the other values since we have enough space right now. We have half. Our density is 1000. This is the density of water multiplied by the second velocity, at the second cross-sectional area, which is indeed 8. So we now have 8 all squared. And if you look at here right now, 0 multiplied by this density and the gravity will give you a 0, so they go away. But now we can continue with this and continue solving our problem. We have that 200, okay, 1,000 plus 500 times 4 will give us a 2,000 is equal to, right here we have our P2, and then half of 1,000 is 500, right? So we now have our P2 plus 500 multiplied by, because this is 8 squared, it now becomes a 64. All right, now let's continue. We have 200,000 plus 2,000. That gives us 202,000. Is equal to, so 500 times 64 this gives us 32,000. Okay, so this is equal to P2 or P sub 2 plus 32,000. To solve for P sub 2, which is the second pressure, what do? We can move this 32,000 to the other side. And we now have 202,000, which is 202,000, minus 32,000. This is equal to P sub 2. So let's see what we shall obtain. Right here we have 202,000 minus 32,000. This is equal to 170,000. So 170,000 is equal to P2. Therefore, we have that our P2 is equal to 170,000 pascals. Remember that pressure is measured in pascals, and you must assign the right units to it. Now, you've seen that the value we got at the second cross-sectional area is less than 200,000. Okay, so as the water leaves, or as the water reaches the second cross-sectional area, which is constricted, you see that this case right here, this place is larger than this part. So the pressure here has to be higher. Okay, P1 has to be higher than P2. As it reaches here, the pressure is going to be lower while the velocity will increase. So that is just how it is. I hope you've understood this concept. In the next video, we shall be solving more advanced problems to solidify your knowledge and to check for comprehension. See you in the next video and take care of yourself. Bye.